Okay, hello everyone. I suggest to start the talk. Thank you for being this number during my talk. So today we'll talk about microservices the right way, and this is the introduction to Istio. I have a question for you. Who is developer in the room? 1, 2, 3. Who is ops in the room? Who is DevOps in the room? Okay. So let me introduce myself. So I'm Laurent Grangeau. I'm a French guy, as you know, as the accent. I'm a cloud solution architect at Sogeti. Sogeti is a subsidiary of Capgemini, a big French company who is doing consultancy on the cloud about native cloud application, stuff like that. And I'm an old developer. And this is a talk which is talking to me, because when you are talking about monolithic versus microservices, so this is on the left, an architecture with the services. So you have big monoliths which are not easy to deploy, which can talk to themselves on defined routes. And on the right side, you have microservices, which is a small unit of services you can deploy every time you want, anytime you want, lots of time during the day, and they talk to each other with a service mesh. So when you see that it's not a really difficult architecture, but when we are talking about the big four, so Google, Netflix, Amazon, stuff like that, it's more like this. So you can't reroute every services by yourself. You have to automate it. You have to automate them by CI/CD or by code. And this is where Istio comes in the place, because Istio is an open platform to manage and connect microservices done by Google, IBM, and Lyft. And yes, IBM is doing some open source. So Istio, I don't know how to pronounce it, addresses many of the challenges you faced when you are dealing with microservices, like A/B testing, plugin deployment, service mesh, of course, service discovery, load balancing, and other stuff like rate limits, policy, security policy, and of course, monitoring and telemetry. When you are dealing with microservices, and you want to debug some microservices in a distributed way, you don't know where your pods are deployed in the cluster, and you have to have something to gather this telemetry, this metrics, this login, and deploy it elsewhere to be able to analyze it. So the concept of Istio is to split into two different things. You have a data plane and a control plane. The data plane injects at runtime proxies, a sidecar of your pod. The proxy is Envoy. You can change it by linkerd. It's the same by that's linkerd. And the responsibility of this proxy is to control on-network communication and to send telemetry to the control plane, the mixer. And of course, the control plane, the responsibility of the control plane is to inject at runtime the configuration, and to route traffic and gather telemetry and enforce policy. So you have 6 different core components. So Envoy is a sidecar of your pod. When you are deploying your stack, your application on Kubernetes, and the Envoy is being injected at runtime as a sidecar. So this is where all the traffic is going, and then is rerouted on your container on the pod. Then you have the mixer. It's a central component that is leveraged by the proxies and microservices. You have the pilot. This is the component responsible to inject configuration of proxy at runtime, so dynamically. You have Citadel. This is for certificate rotation and insurance. It's the same with Node Agent. And you have a broker. So the broker is a work in progress. It's based on an open service broker, which is developed by Pivotal, I think. And then you can talk to external services like Microsoft Azure, AWS, or stuff like that. So this is a global architecture of Istio, and we can see that you have all the different components I talked about. So you have the pilot, the mixer, the Citadel, and on each pod you have the proxy here, which is being injected as a sidecar of your container. The communication between these components is based on HTTP 1.1, HTTP 2, or gRPC, with or without TLS. So you can enforce TLS routing or TLS communication between your pods with Istio. So with that, you can enable traffic management, discovery, layer 7 routing, and circuit breaker. You can have a circuit breaker. You can handle fault traffic. For example, if your services or microservices doesn't respond in 1 second and 500 milliseconds, you can return an HTTP 5xx and just stop the call. And this is important when you have web services, web pages, for example, and you don't want the people to just wait until the page is fully loaded, and you have all of this environment. Of course, you can enforce policy. You can see, you can define what container can talk with each other. You can enforce policy on ingress, and you can enforce policy on egress. So you can say that containers cannot talk to the outside world, internet, for example, or stuff like that. You can have distributed tracing. We will have an example of that based on open tracing. So you have two kinds of implementation. Zipkin, which is developed by Uber, I think, and the other one, I don't remember the other one. And of course, you can enforce security, authorization, authentication between your pods and between your containers. Okay, so to demonstrate that, I have an example of the application. So it's a simple application developed with lots of different languages. You have the product page, which is developed in Python. You have a Java services, which is 3 different services. So you have the version 1 of review, which doesn't call the rating services. You have the version 2 of review, which called the rating services, but only return gray stars. And you have version 3 of the review, which display red star. And you have the Ruby for the details pages. So this is an example of an application developed in Kubernetes. So this is how you deploy or design your stack. And with Istio, this is a little bit different because each black box here is the envoy proxy. So you see that the envoy proxy is injected at runtime on your pod. So all of this envoy proxy just manage and control the traffic between all of the services. So this is how Istio can, at runtime, just change this behavior, like having A/B testing or canary release or blue-green deployment and stuff like that. Okay, so now let's go to the demo. The Wi-Fi is a little bit not stable, so I praise the God of demo. So this is my front page of my beautiful application, and you can see that there isn't any star on the pages. If I hit refresh, you see normally that we have some black stars, and if I hit refresh again, we have some red star. So the application is like I designed. So it's routing like round robin. So review V1, review V2, review V3, and so on. So if I hit refresh, you can see that the page is cycled. Okay, so now I have some example. If I go there and just show you, do you see? Yes? Okay. So this is an example of a YAML file that defines all of the route is based on V1. So if I apply that on my application, we will see that when I hit refresh, it's only the review V1 that's being deployed. And it's been done by saying that all of the routing is based on V1. So if I apply that, just before I will show you that no routes are defined. And if I apply that, I have created some config route. And if I go back to the routing rule, so we have some default routing rule that say that the rating and review is toward the V1. And if I hit refresh on the Simple Store, you see that there is no star displayed. So this is the default routing. I have dynamically reconfigured my application to be able to have the review one. So now, let's go to some A/B testing. I will define, sorry. For some user, the user is named Jason. Based on the cookie he have, I will just route him to the version 2. So this is defined with the destination. So when the destination match the user JSON, they will be routed to the version 2. So I apply that YAML file. Okay, and I just go back to my application. So my application has a default V1 route and has an A/B testing route with a user JSON, which will be routed to the version 2, so the black star. So if I hit refresh, you see that there is no star. And if I log in, you see that JSON only sees the black star. So this is a very convenient way to do A/B testing without redeploying or without configuring a routing layer, and only based on YAML file and code. So this is A/B testing, and you see that if I go to see the rule, so you have the review default, which is configured, and review test v2, which is applied. So this is my A/B testing. Okay, so this is only for A/B testing. I will just delete the file I've created. Okay, so if I go back, you see that the behavior of the application is only to have round robin review v1, v2, v3. If I sign out, you see that it's the same. So this is a very convenient way to do A/B testing. I can do, for example, canary release. So this is a canary release. 15% of the time, I just routed to the v3, so the red star, and 50% on the other side is no star at all. So I reapply the version 1 to have a default route, and then I apply my canary. So my canary is 15% of the time you have the V1 version of the review, and 15% of the time you have the V3 of the review. And if I apply that, you see that if I hit refresh, you have no star and the red star, and so on and so forth. So this is a very, very convenient way to have A/B testing without implementing something in your application, like if this is a new group or this is a beta group, you can route that in this. And now, so this is a canary release. So now my canary is okay. I've got no HTTP 4xx code. All is okay, so I can apply all my routes to V3. So I just change the weight of the V3 routes to be able to have 100% of the traffic routed to V3. And just applied it. And you see that if I hit refresh, I only see red star. So you see that all I do is applying YAML file. So when you have, for example, a stack with Kubernetes, your application, and some YAML file, you can do with CI/CD stuff like immutable infrastructure, A/B testing, canary release, all with code. So you don't rely on ops team that deploy and reroute and reconfigure. You can do it all by yourself. Okay. And you can have a circuit breaking. So circuit breaking is a simple thing. Which of you knows circuit breaking? Okay, so half of the room. So circuit breaking is something you implement in your code that says that if the database doesn't respond in a time, for example, 2 seconds, you just like a fuse, you just go back to something normal or return on HTTP 5xk. So to demonstrate that, I will just inject some new application. So I have deployed a new application called HTTP bin, and I will route the HTTP bin, so V1. So this is a different thing from the architecture application. This is a new application. And if I apply some rules that create 100% routing to the application, you will see that HTTP bin can respond. And now you can define the circuit breaker. So I will explain what you have here. So here you apply a new destination to the HTTP bin with some max connection, a max pending request equal to 1. And you have a detection interval of 1 second. That says that if the application doesn't respond in 1 second, the circuit breaker will trigger and we will have an error. So I apply that. And you'll see that there's a new destination policy to the circuit breaker that has been applied. And we will stress test the application to see that the circuit breaking is in place. So for CO is the tools to stress test your Kubernetes application developed by the same team that develops Istio. So it's only a stress test tool. So I just got the for CO pod and I just curl the HTTP bin. And it's not working. Okay. Okay, so it's not working. I don't know why. Maybe. Okay, so it's being deployed. So we will wait a little time. But the concept of this circuit breaker is when you have, for example, a service that takes longer than 1 second, for example, to respond, the circuit breaking will trigger, and we will return a HTTP 5XX code to be able to display the page without affecting the performance of the overall application. So, yes, it's deployed. I get the pod, and I just curl. Okay, so it's not working. Yes, it's not working. Okay, so I will just try to explain what's going on. So for Istio, normally stress test the application, the HTTP bin, and just make 2 concurrent connections at the same time, and then we make it to 3. And as an example, we will be able to see that 50% of the time or 33% of the time, so 1/3 of the time, you have the response, and 2/3 of the time you have no response. So this is the circuit breaker, which is doing its role and not responding to the stress testing tool. And you can for example, apply that to your application and just deploy your application without coding that in your application, because circuit breaking is sometimes code by the developers, and it's hard coding in their code. So it's not the good way to do that, but it's better to do this that way. Okay, so just one last demo. I will just show you is Zipkin. So Zipkin, as I told you, is distributed tracing implementation of open tracing from Uber, and it's something very convenient because you can find traces. You can find traces on your overall cluster, Kubernetes cluster, and just analyze it. So I just find the trace I stress test my application. And you see that you have, for example, the application that responds in 500 milliseconds. And in this 500 milliseconds, when you click on that, you can see all the mean time of each services and which service take the longest time to respond. For example, the product page here waits 81 milliseconds to the details services to respond, and you can work with that easily, because with that you can see that which services is not responding or which services is taking the longest time to respond, and you can work on that to be able to better code your microservices, or to reboot or apply some circuit breaking or stuff like that. So this is a very convenient way to see all the trace the application generates without knowing where your application is being deployed on the large cluster. So you don't have to implement some kind of trace or logs or stuff like that. Just using Zipkin is a very convenient way to see the trace of your application. Okay, so do you have any questions so far? Yes? So the question is it working only with Kubernetes? Actually, it's a first-class citizen for Kubernetes, but you can try it with Docker Swarm, for example. And it's all kind of Kubernetes, so you can deploy it on IBM, on Azure, Amazon. So yeah, it's not working only with Kubernetes, but it's a first-class citizen. Do you have any questions? No, everything's clear? Yeah? Who wants to try it? Yeah? So I will go back to the architecture. Okay, so actually, every square is a pod. So here you have some pods deployed, and I can show you that it has been deployed. So here you have all of the pods deployed in a separate namespace called Istio system, and you have the ingress part, the mixer, the pilot, and some other stuff. So you have Prometheus, Grafana, and Zipkin, but it's deployed with pods. The only part that is not deployed within this namespace is the proxy. So the proxy are injected as a runtime, as a sidecar of your other parts. So you have two different things. You have the namespace Istio system with all of the necessary pods, and you have the envoy proxy, which is deployed as a sidecar of your application. Yes? Is it working with a network plugin, or is it integrated with a network plugin? So it's okay. So when I deployed Istio, I deployed it like that. I don't play with the network plugin, but it's over the network plugin. So it's defined its own networking system, its own routing system. As you can see here, the routing is based on envoy proxy, so different proxies. And this is how Istio can enforce policy, enforce telemetry, apply, for example, RBAC or ingress or egress rules, like accept going on the external world or stuff like that. And this is how Istio can achieve certification and mutual TLS. So with envoy proxy. So it's over on top of the network plugin. Yes. Sorry? Can I talk about a little bit on authorization? Yes, of course. In the Istio world, you can define. I think I have some. No, I don't have any demo, but you can enforce authorization, authentication between containers. So it's not airbag like service role, cluster binding, stuff like that. It's part of the Kubernetes world, but it's really when you have, for example, two sets of container or two sets of pod that can't talk to each other. So the envoy proxy defines the route between the different proxies and the mixer itself. So the mixer on the architecture here. Enforce authorization and authentication between pods. And Citadel, at the far right, define certification, authentication, certification rotation, and mutual TLS authentication. So this is not plugged in an airbag system. You can continue to use airbag system of Kubernetes, but it's to isolate some sets of pod between each other. Yes? Yeah? Okay. So, up. Oh, oops. Oh, okay, so this is a YAML file of the all of the system. And you see that, for example, if I go back to the details v1, so you see that the container deployed is in this one with the name. And there is no specific configuration of the YAML. So it's at runtime that envoy proxies are getting injected by the Istio router. Yes. Yes, I'm sorry. Istio inject the container with the Istio curl, I think. I think it's yes, with the kube inject. It's part of the Istio system. So when you deploy your application, Istio curl inject the envoy proxy at runtime with this kind of kube inject policy, kube inject command, and it's wrapping the container with a sidecar in the pod. So the exact implementation, I don't know exactly, but this is how it's done.
There's initializer Kubernetes. When you deploy a work,
Mm-hmm.
there's a concept of initializer which inject this envoy.
Maybe. Any questions left? Okay, so thank you very much and have a great evening.